I was once told by a colleague when I started giving lectures in meetings like this that one of the worst possible times to give a lecture is right before lunch. But the very worst time to do it is right after lunch, especially if it's a warm room. So what I'd like to do today is talk a little bit about a project. It's our SIGS project, and I can see that I need to, let's see, let's start at the beginning. SIGS is a publication, and so in a way it's kind of interesting that we've heard a lot about much of the data gathering and a lot of the other kind of things we're doing at the beginning of the process. SIGS, on the other hand, is a little bit about the academic credit that most people want or that we're still expected to have, and that's ultimately in arriving at a publication or a set of publications that are very important for most people in academic positions as well as in industrial positions, where you want to actually document what you've done, because it becomes very important to tell people not only what you've done but how you've done it. And this is something that we had some indication about a few years ago when we started the journal. I'd like to tell you a little bit about the background, but before that, what I'd really like to do today is, for those of you who've heard me talk about this before, I'd also like to bring you up to date. For people who are involved in publishing, June is perhaps one of the most important months. June is when people get their impact factors. It takes roughly 2 to 3 years for a journal to publish before we get an impact factor. And we're quite happy that SIGS got its first impact factor from Thomson Reuters in June. We now have an impact factor of 1.62, and it's actually moving up as we move out from those first 2 years of publishing. The other thing is that SIGS is now beginning to publish formal taxonomic proposals, part of what are called effective taxonomic proposals in the prokaryotic nomenclature, which is really interesting because the names that are being proposed now are getting standing in the literature as well. The other thing is that SIGS continues to be moving into additional abstracting and indexing services. We've been accepted in Chem Abstracts this year as well as EBSCO. And the other thing is we've converted to a pay-to-publish model. We're still a gold open access publication, but at the same point in time we're working to become a self-sustaining publication. So SIGS has a kind of an interesting history. It started 4 years ago at GSC8, was it? 6? I can't remember. It's so long ago. 5? 5, okay. So we started at Jesus College in Cambridge, and Nikos Kerpides, Don and I were in a small room, and we were sitting having a conversation about what we wanted to do next. And Nikos brought up a really interesting point, and he was quite concerned that at that point in time, as the number of genomes were being sequenced at JGI and elsewhere, what they were finding is that the number of genome publications was beginning to lag. What this means is that the formal announcement of a genome was essentially disappearing from the literature. Now, it's obvious that journals like Science and Nature wouldn't want to continue to publish genome sequences because they always like to be out on the cutting edge. That's the way they drive their impact factor. But at the same point in time, the people who are associated with generating the data weren't getting the academic credit. And so as we were having this conversation, it became obvious that one of the things we might want to consider for the Genomic Standards Consortium was to establish our own publication. And I foolishly decided to step up and say, yeah, why don't we give this a try? And what we subsequently did was we published an article, and we were at that point in time published in a journal called Omics. We published a proposal to have a publication that would have very highly standardized publications that would pertain to the kinds of things that a standards organization would be pushing for. And these included a number of different kinds of papers, but most importantly, genome papers that could be standardized and then distributed in a very easy to edit and a very easy to read way. Now, what's rather interesting, I showed this last slide. I made this one for the GSC14 meeting. And what we're now finding is that there's been an uptick in the number of genomes that are actually appearing in the literature. One of the reasons is because Standards in Genomics has been doing this now for several years. But we also find at least one other journal, as you'll find momentarily, has also picked up the charge, and they continue to publish genome reports, while many other journals have essentially fallen by the wayside. So this is what Standards in Genomics looks like. The web address, the URL is at the top. It's a fully open access publication. It is published using the Open Journal system from Simon Fraser University. It's open access publication that's published using open source software. It's extremely stable. We're pretty happy with the way in which we've been able to essentially develop this interface, and it's one of the first examples of an OJS publication actually getting into PubMed Central and many of the other indexing services. And so you can see what it looks like also from the PubMed site, PubMed Central site, so you can pick up the journal either from us or on PubMed Central. Now, as I mentioned, one of the things that we wanted to do at the beginning was to publish papers using a highly structured format for the articles. This makes them much easier to read. This is an example of a complete genome paper that was published a couple of years ago. And what we do is we have a description of the organism. It provides information about the source of the organism, provides information about the genomic DNA isolation, how we actually sequence, how the organism was actually sequenced, the assembly and the annotation, all of the things that come out of the use of mix and MIGS as standards, and we actually use all of the codes in our tables so that you can actually pick up the information and essentially replicate it from the tables that are published in an accessible form in HTML as well as in XML, and you can actually pick these files up and actually use them. So we also want not only humans to read the articles, but also machines. One of the other agreements that we had was this idea about looking at standard operating procedures. As most people know, when you read an article, if you read the materials and methods, it's usually too brief to actually replicate what's been done. And so the idea was to actually use a much more detailed standard operating procedure so that people will understand how pipelines will run and can actually replicate the pipelines as well. And so the SOP papers have actually been very well received as well. We've also have a number of other kinds of papers. These include research papers. We have editorials, white papers, and one of the other papers we began publishing about a year ago is genomes that are published outside of standards in genomics, and we're scanning the literature all the time so that we can actually publish these papers as well. And so at this point in time, we've published 248 papers, and you can see the breakdown in terms of the number of papers we've actually published. We have 183 genomes we've actually published, and we have approximately 30 sitting in our queue. Now, since I'm a publisher, and since this has really become a core activity for the Genomic Standards Consortium, one of the other things we like to do is to see how well our efforts have been accepted by the community. What's really interesting is that we have a near doubling per year in terms of the number of articles and downloads of the articles that are being picked up by the community. And we also see that the number of articles that are being picked up on a daily basis is approximately 300 per day from the collection of articles that we have online. If you look at the distribution of our readership, we have readers in 152 out of 193 countries in the world. Quite a few cities. And what's also interesting when you look at the distribution out of Google Analytics, you see the distribution of the cities that we have mimic pretty much the large sequencing centers that we saw in Dawn's presentation this morning. And so the only place where we don't see much coverage right now is in South Africa. And I think we probably have a little bit more coverage right now in India than you do in the big sequencing centers. In terms of the efforts in general, we are quite happy to find that SIGS is now the second largest publisher of genome articles in all the publishers. We've moved up from, we started at about, when we started looking at this, about 5th place about 2 years ago, and we continue to move up. The one that's really kind of beating us these days is Journal of Bacteriology. They have extremely brief and non-standardized genome reports, and they continue to publish quite a few of these very quickly. So one of the things that we have also done is we've looked at our workflow from an editorial perspective. What we'd like to do is to make sure that everything that we do is fairly fast, but also efficient. And so by using templated articles, this allows us to essentially move through the process pretty quickly. The peer review process is one of the things that continues to slow us down, obviously, as we increase the number of papers that we want to publish. Getting an adequate number of reviewers to review all the papers is problematic. We use a number of different editorial tools. Perhaps the most important is one called Xstyles. Xstyles is a very nice tool that a lot of publishers use. It allows us to take a Microsoft Word document and produce XML that's compliant with the National Library of Medicine's document type definition, which is required for posting in PubMed Central. It also allows us to integrate and link in information about biological nomenclature through the Names to Life tools. We also pull in all the references through Crossref and PubMed Central, so the document becomes highly linked as well. The process itself, as we move down through the workflow, is pretty straightforward now. It doesn't take too much time, although we've been modifying the workflow a little bit recently so that we can actually produce the PDF articles ahead of time, so that we can actually expedite the process for some of our larger authoring groups, most notably the GIBA project from the German National Culture Collection and from the Joint Genome Institute. This is an effort in which we're sequencing all of the type strains of Bacterium archaea. We've already gone through approximately 1,500 sequenced type strains, and these are sitting in a queue, and so getting each one of these publications going through means that we need to actually have a standardized article, and we're working on ways in which we can actually use machines to speed up the process as well, including text generation. The other thing, as you note, we've been picked up in a number of different indexing systems, and we're pretty pleased by this because the more indexing systems we're picked up in, that means the more opportunity you as an author would have of having your articles seen by others. The other point is that we're now charging a $555 article fee for the publication. As I mentioned, we have annotation tools. These annotation tools pick up not only the references, but biological nomenclature, and we're also working on phenotypic ontology that will allow us to essentially annotate all of prokaryotic phenotypes as well. So what I'd like to do is kind of wrap up here quickly, since we've been picked up now by the indexing systems. For those of you that follow impact factors, I just thought I'd show you a few things that are kind of interesting when we start following these. There are 3 different sources right now where we can actually pick up indexing data. Thomson Reuters is perhaps the most commonly used, and that's the one most publishers are looking for the impact factor that is most widely used. But what's really interesting is that Thomson doesn't have that deep of a coverage, and they tend to lag behind most of the other indexing services. Crossref is a part of a consortium that was established by the commercial publishers about 15 years ago. They're the ones who issue digital object identifiers to articles. And what's rather interesting is that members in Crossref are now submitting all of their articles in advance of publication. And what this allows us to do is to also pick up the Crossref links, and we play in the linked by consortium so that we can actually follow the number of different citations of SIGS papers, both in SIGS and outside of SIGS. And as you can see, there are actually far more references, and this would actually drive up our impact factor based on those number of references. And we also find that Google Analytics is now doing a very nice job of providing additional information about where the linking is occurring. So if you follow all of the bibliometrics, or if you're interested in this as an author, it becomes really important to follow not just one, but multiple sources. So let me just show you a couple of other things in terms of our article counts. As you can see, our short, yes? Oh, okay. So yeah, I've got it up here in front of me too. So a couple of things, just show you a little bit about the number of articles that we have. As you can see, the short genome reports are among the most dominant ones. But as we move through and we look at the total reads also follow this, rather substantial number of reads, a slight difference in the way in which this appears. The daily reads, we're actually finding that we have more daily reads of some of the less frequently published classes of articles. And this is the way our citations are appearing. We have quite a few citations right now. We have, for the 248 articles that we've published, including ones that just published a few weeks ago, we have approximately 800 citations now. And this is what our impact factors look like if we break them down based on the article type. And so when one looks at just an article and they say this is my impact factor, what's really, really amazing is the articles that we would think are picking up the most, just because we publish most of them, The short genome reports get quite a few citations, but we actually find that the research articles, the meeting reports, and some of the others would have a very much higher impact factor than is just shown for the articles in general in the publication. Of course, one of the other things is that we're talking about in this meeting about phyla, and we're talking about the way publications go. And so we can break down the short genome reports based on the phylum as well and let you know and get a glimpse of what we're publishing in SIGs. And what's really interesting is then if you look at the article impact factor by phylum, it's just a little bit different as well. And so this is just slightly different way of looking at the data. So one of the things that's been kind of interesting about SIGs is it does actually provide us with a sandbox. We can play around with our own publication. We can see how it might meet our needs. And one of the long-term objectives is actually to integrate data much more tightly into a publication and also to make the publication much more amenable to doing machine processing on it. So we're looking at new ways of doing publications to present the information as well as to capture more of the information. As I've already mentioned, we're now beginning to publish taxonomic proposals. We're also looking at ways of standardizing phenotypic descriptions, at least for the bacteria and archaea. And we're also looking at ways in which we can do semantic enrichment of content so that we can integrate SIGs articles much more tightly with all other articles. And with that, I'd like to thank everybody for their time, and I'd also like to thank all of the authors, reviewers, and the editors for SIGs. Thank you very much.